look at this question here. We have to prove the identity. So of course we're going to take the left hand side and then we work it out to make sure that it's the same as the right hand side. So we choose the left hand side. Here's our left hand side. Then the next thing is to expand this. Remember, this is the compound and for cos sine times cos sine as well. Here we go. The next thing is to multiply each brackets here. We need to multiply and we apply FOIL method, this and that one, and we times this one as well as that one. So it's going to be cos times cos, which is going to be cos squared, and cos times cos is going to be cos y squared. And then the next one, we take that side, which is cos x and cos y, times that portion, which is sine x and sine y. And then we do the same here. We take those one times, which is this portion. So the last part is to take those ones and multiply together with that one. Because of I don't have a space, I'm going to write it over here. Sine times sine is going to be sine squared, and sine times sine is going to be sine squared. We are done. The next thing is to collect like terms. We can see that sine x, y, cos x and cos y is the same as this one, and the other one is positive and the other one is negative. Then therefore this one is going to nullify this one, so we're left with this one, negative sine square x and cos square x and sine square x. We're done here. The next thing is to change cos x. Remember, cos square x is the same as 1 minus sine square x, and we do the same here. Why? Because what we are proving here, it only have sine, there is no cos here, so that's why we have to change cos and cos. All right, done. So we're gonna have sine y and cos sine x. Mean for cos x, we drop this one as it is. Then the next step is to multiply out these two brackets, 1 times 1, 1 times sine, sine times 1, sine times sine. Now simply, so this is what we have after we've multiplied out these two brackets. So 1 times 1 is 1, 1 times sine it's sine, and sine x times 1 is sine x, and sine x times sine y is sine x times sine y. Now we have to drop that portion as it is. We are done now. So you can see that sine square x times sine square y is the same as sine square x times sine square y, and other one is plus, other one is negative. Therefore the rule allows us to cancel this and this one, so therefore we are left with this portion. We just drop it as it is. So we are done now, because what we were proving here, that was 1 minus sine square x, 1 minus sine square y. So same here, 1 minus sine square x and minus sine square y. So we're done. Then we just conclude by saying therefore our left hand side is equal to the right hand side. So we're done now.